A microtome is a precise instrument used in pathology laboratories for cutting extremely thin and uniform sections of tissue so that they can be placed on glass slides and examined under a microscope. Microtomes come in different types depending on the type of tissue, embedding medium, and section thickness required. There are many types of microtomes. For example, sliding microtome, where the knife slides horizontally across a stationary block, and commonly used for large tissue blocks, for example, for the brain and the lungs, and common in neuroanatomy and research laboratories. Number 2, freezing or cryostat microtome, whereby the tissue is frozen rapidly and cut in a refrigerated chamber or in a cryostat, and produces sections without embedding in paraffin, and majorly used for rapid diagnosis during surgery where frozen sections are produced. So it is very useful in histochemistry and lipids demonstration since lipids dissolve in paraffin. Number 3, ultramicrotome, in which a very fine mechanical advance moves the block against a glass or diamond knife to cut ultra-thin sections. It's majorly used in electron microscopy and essential for studying subcellular structures like organelles, membranes, and viruses. Number 4, vibrating microtome or vibrotome, in which a vibrating blade slices fresh or fixed tissue, and it's majorly used in neurophysiology and immunohistochemistry. Number 5, rocking microtome, in which the block is rocked against the knife in an arc motion. It is an older design mainly used for paraffin section and produces ribbons, but with less precision as compared to rotary microtome, and historically used in teaching laboratories. Number 6, rotary microtome, in which a rotary movement of a hand wheel advances the block against a stationary knife, and used for routine paraffin embedded blocks. This kind of microtome produces thin sections for routine histopathology and diagnostic microscopy. So rotary microtome has been widely adopted because of its precision and uniformity of sections. Number 2, versatility, whereby they can cut a wide variety of specimens, soft, hard, large, or small biopsies. Number 3, efficiency and speed. So the rotary mechanism allows the user to advance the specimen and cut continuously with minimal effort. Number 4, ease of use and safety, whereby features like blade guards, trimming knobs, and adjustable handwheels improve safety and precision. Number 5, reproducibility. Fine adjustments in rotary microtomes allow highly reproducible section thickness, which is critical for consistent staining and diagnosis. The major parts of a rotary microtome include: number 1, knife holder or blade carrier, which holds the microtome knife or disposable blade securely. Number 2, thickness adjustment, cutting or sectioning knob, which is usually linked to the hand wheel or integrated into the thickness adjustment system. So this sets the exact thickness of sections to be cut, for example, at 1, 2, 3, or 4, 5 micrometers, and ensures uniform thin sections for microscopic examination. So each click or setting corresponds to a precise advancement of the block towards the knife. Number 3, the blade guard, which is the protective cover attached to the knife holder of a microtome. This prevents accidental cuts to the operator's fingers when placing or removing blocks or when cleaning the microtome. Number 2, protects the knife edge from accidental damage, e.g., contact with tools or debris, when the instrument is not in use. And number 3 allows the user to safely change the blocks or adjust settings without removing the knife each time. Part number 3, hand wheel or fine adjustment. This moves the block holder up and down past the knife to cut section. Each smooth rotation results in a single thin section being cut. And with each turn, the block is advanced forward by the preset distance, for example, 3 to 5 micrometers. Number 4, locking mechanism. This locks the hand wheel in place for safety when changing blocks or blades. Number 5, block holder or chunk. This holds the tissue block or paraffin block and can be adjusted in multiple directions to properly align the block to the knife. Number 6, coarse feed wheel or knob. This moves the block holder towards or away from the knife in large steps and mostly during trimming. Number 7, trimming knob, which sets the thickness at which the block is trimmed to cut away excess paraffin and expose the tissue block or the tissue to the blade. Number 8, removable section waste tray, which collects paraffin debris, keeping the working area clean. Number 9, advancing mechanism or the feed mechanism. This moves the tissue block holder forward towards the knife by a preset distance after each rotation of the hand wheel. This ensures that each cut is of a uniform thickness. So inside the microtome, there is a precision screw and ratchet gear system. So when the hand wheel rotates, the mechanism advances the block holder by the amount set on the section thickness knob. For example, 3 micrometers or 5 micrometers, so on and so forth. So this step-by-step movement allows the knife to cut section of consistent thickness. Number 10, section counter, and this is optional in many models, which counts the number of sections cut. Additionally, microtomes have got a sample orientation system which allow tilting or rotating the tissue block or specimen holder in different directions. This ensures the cutting face of the block is correctly aligned with the microtome knife. Number 2, the lateral movements in a microtome, which ensures even use of the knife or blade. So the disposable blade edge is very sharp but also delicate. By shifting laterally, a fresh portion of the blade can be used instead of using the same part repeatedly, and this prolongs the life of the blade. It also improves the section quality, as a dull or overused spot of the blade can cause chatter, tearing, or compression of the tissue, and also prevents premature disposal of the blades, saving cost in the lab. Front and backwards movement. This moves the entire knife holder assembly forward or backward relative to the block, and this brings the knife closer or farther from the block face. It therefore adjusts the distance between the block and the knife. Cutting angle regulation system or clearance angle adjustment. This changes the tilt of the knife edge relative to the block face. So it adjusts the clearance angle normally between 3 to 8 degrees to ensure smooth cutting. With too small angle, for example between 0 to 2 degrees, the blade edge rubs against the block. Hence, sections wrinkle, compress, or do not cut at all. And too large angle, above 10 degrees, the blade digs into the block, causing chatters, tearing, or block damage.